Further, now let's look at the small and middle-sized cloud management campus network design. And you shall notice that it is about the cloud management campus network. So you will find that the name is different from virtualized campus network. So what is different? We will see in the lessons. And we shall know that what the cloud managed campus network is used for. It is used for the small business. So now you shall know that the small business and the middle skilled scenarios, and for example, the chain stores, the branch office, and the chain hotel, and the amount is the amount of them is increasingly, and for these scenarios, they are virtually connected to the enterprise internal through cloud management networks. And we have a report that shows the record difference between traditional products and cloud-based products in terms of the annual growth rate from the 2040 and to the 2080s. For example, the annual growth rate of the traditional Wi-Fi has only the 5% 1 year, while that cloud Wi-Fi was the 38%, and the annual growth rate of the traditional switches and access routers was just 2%, whereas that of cloud switches and access routers was as high as the 51%. So you can find that cloud managed networks have become the trend in constructing small and middle-sized campus network. So we need new solutions to help the enterprise improve the management efficiency and build networks that can quickly support the development of the new service. So we'll introduce a new solutions, and this solution is based on the MSNCE campus, and the solution name is Huawei Cloud Campus Solution. And we will use the cloud computing technologies to implement automatic and centralized network management, and it will provide data collection and analyze capabilities that are available on traditional networks. So we can treat the network as a service. And now let's look at what is the small and middle-sized campus network, and what is the trends and challenges. First, let's look at what is the challenges that faced by the small and middle-sized campus network. The first is the industry change, and another is the problems in traditional development and management solutions. Now let's look at the first challenges. And we can find that network cloudification brings rapid development in the new ICT technologies. So for example, the cloud computing, cloud security, big data, and IoT, and all of the new technologies leading to tremendous challenges in all industries. For example, for the traditional retailers such as shopping malls and supermarkets, offer free Wi-Fi as a way to attract and retain customers. And they also use wireless positioning and customer flow analytics to carry out precision marketings. In education sectors, e-classroom are becoming more and more popular, and field multimedia teaching method further stimulated students interested in learning. So you can just find that in many industries, the requirement changes. So the requirement changes, and it requires the network changes. And another problem that you can find that in the traditional network. The first is the low deployment efficiencies. For example, if you want to open a new branches, for example, you need network engineers to build the network for the new branches. It will cost a lot of times. And for the traditional networks, I mean for the small business, if you want to manage the device, and you will find that it is difficulties just because for most of the branches or the small office, they only have one internet links. And normally, I mean in China, the uplinks of the small branches, they don't have a fixed IP address. It means it is impossible for the management personnel in the headquarters to manage the device remotely. If the device fails, normally the network engineers need to go to the small business to fix it. That is how OPEX, all right. And the last one is the poor network openness. It means for the traditional networks, for the small business, for example, for the headquarters, they have so many small business, and for example, the chain stories, and they have so many data that from the customers, but they don't have the abilities to analyze them and use them to make smart or intelligent decisions for them. And now, next it is the service requirement analysis for small and middle-sized campus network. The first is the plug-and-play network device. We improve the deployment efficiency, and I have already shown you guys just yesterday, and you can find that all the devices, if you power on them, they can register to the controllers by themselves. And then the next is the cloud-based centralized operation and management. So what it means? It means we will deploy an NCE campus on the cloud, on the public cloud, and for you just need to register an account on this platform, and then your device can register to the platform, and then you just binding you device ES numbers with your account, and then you can manage them. That is the cloud-based centralized operation and management. And the next is now we have already used the centralized management, and you should know that it is the NCE campus. And the NCE campus can offer open APIs, and you can use these APIs to do maybe the business analyze, and maybe you can use it for the business purpose. And next is about the trends in the small and middle-sized campus network. We can find that the first one is the network qualifications, but it means now the management of the device. It is not traditional. We can manage them on the controllers, and the controller is on the on the public cloud, and you don't need to manage them by the command lines. And that problem is the security is just because maybe we will use just for the qualifications. You will find that the enterprise, maybe they don't have the abilities to avoid attacks from internet, and you will find that the boundary of the network just will become not so clear like the traditional networks. If you deploy the cloud virtualization technologies on your campus network. And the last one is IoTs. For example, for so many and you can find that for so many scenarios now, we have IoT device, and this device will connect it to your networks. But you should know that the IoT device, they use the different protocols. For example, they will use the ZigBee, all right, or maybe another protocols, but it is not the Wi-Fi technologies. So how let them connected to your networks without by an additional device? So that it brings a new requirement for network device. That is required. It is maybe campus AP, the wireless router in the campus network should be ability to offer the connectivities to IoT device. It means they should to support the ZigBee module or other IoT protocols module. So now let's look at what is the Huawei's Cloud Campus solution for small and middle-sized campus network. you find that we call it cloud management, just like I said it before, just because we have a platform and this platform is deployed on the Huawei's public cloud. And you can find that for these solutions, we have three parts. The first part, the underlay is the tenant network. It means your networks, the customers networks, and all the networks will register to the cloud management platform. And actually, you find that it is the MSNCE campus. And after it, it is the value-added SaaS platform. It means for this part, it should be made by the customer itself. For example, the MSNCE will offer you APIs, and by these APIs, you can get some data about your networks, and maybe you can use this data to do analyze about you. For example, your traffic, the traffic of your store or the traffic of your hotel. And now we can see what is the physical architectures of the solutions, and you will find that it is still the three levels: multi-tenant networks and cloud management platform and value-added SaaS platform. And you should know that for this part, it is made by the customers. For example, the customers can use the API to build the software by themselves, or the customers can purchase the software from another software companies, and they just open the APIs. So what is offered by Huawei? Huawei offered the cloud management platform, and for the network, it is built by the customers. And you can find that for different scenarios, we have different typical topologies. For example, for the mini store, maybe only one AR or the AP can function as the branch networks. And for the hotel, you will find that we will have a lot of APs, and the APs is a remote APs. Okay, we call it remote unit, just because we have the central AP and a remote unit. Central AP maybe just one floor, we have one central APs, and for different room, we will deploy a different remote unit. And now, for example, for the supermarket and the shopping mall, you can know that the room is more bigger, and the topologies will be more complex. And for the shopping centers or primary, secondary schools, maybe the network scale will be larger. And now let's look at, just have a brief look, what is the component for the Huawei Cloud Campus Network Solutions. And you can find that the cloud management platform, it can include the MSNCE campus, MSNCE campus inside that we will introduce in the next lessons. And we have the registration centers, and I will introduce what it's used for. And you can find that for the platform, it is based on the Huawei public cloud. And we have so many devices, and those devices, I mean, not every module of Huawei device can register to the MSNCEs. And it means all the devices that is support management by Huawei Cloud platform. And what is above the MSNCE? It is the support system. For example, the Server Cloud or the ESDP platform. The ESDP is used for delivery the license for your device. And we have the PKI platform that is used to generate the certification fields. You should know that if we want equipped communications, we will use the SSL technologies. And for these technologies, we need a certification field, and that is generated by this platform. And now let's look at the solution component. The first one is the MSNC campus, and I think you should know that what it is. It is a controllers, and this controllers can provide the automated configurations generated and pushed to device. Or as you know that, and besides that, you can use it to management, control, and analyze the network. Just use these controllers, and also you can use it to optimize and maintain your network in your daily work. And then we will introduce a new component, and I think you never heard it before. It is the registration centers. What it is used for? It is used for these scenarios. For all the devices that support cloud management, after they power on, they will try to connect it to the Huawei registration centers, and they will require the IP address and the port number of the cloud management platform. And how Huawei registration centers knows which platform you should register for. That is, Huawei registration knows the ESN numbers and the MAC address. They have mapping tables. And for example, you build an MSNCE campus, and then you input the ESN and the MAC address of the device, and then you controllers can just synchronize the ESN and the MAC address to these centers. And after the center receive the required information, she will look in the MAC address and ES numbers to search which MSNCE platform you belong to. So it means the MSNCEs can be Huawei's MSNCEs, and you should know that we deploy MSNCE on Huawei public cloud. And if you don't want to use the controller that offered by Huawei, you can build it by yourself. The only thing you need to do is you need to synchronize your information to Huawei's registration centers, and then your device can require your controller's IP address by using the center. And then after the device obtain the IP address and port numbers from the centers, it will try to register to your controllers. That is the registration center. And what is next? And the next is the MSNCE Campus Insight. It is a platform that you can use it to management your network, and you can use it to AI-powered intelligent operation and management. And we will introduce in the next lessons. And I think the most important thing you should know that the MSNCE support the traditional SMP protocols to management the device and collect information from the device. Besides it also supports the more powerful telemetry technologies, and for these technologies, it can collect more information by health frequency. And without more information, you can make a more detailed decisions for your network operation. And the next component, it is the WLAN planners. What is used? This is used to, before you deployment your APs, your wellness networks. You should know that we need to do a plan, and you can use this platform to do the signal simulations. You will know that, for example, you can put an AP on this device, and you have a map about your physical rooms, and you will know that what is the scale, what is the coverage of the APs, and for this place, the signal values will be the accurate values about the single value. And what is next? It is the Cloud Campus apps. It is apps that you can install on your smartphones. By use these apps, it means, for example, you have apps, and you can know that on the apps you will have a QR code, and you use these apps to just scan it, and the app will try to upload the information to the centers. So you will find that just by use these apps, you can just to simplify the information collection about the campus device. And besides that, you can also use it to do a simple deploy, but it's just for the wellness scenarios and deploy the APs. And for the physical layers, I mentioned it before, so not every device of Huawei can support be management by this platform. So we have already shown which modules of the Huawei device can be management by the platform. You can find that for switches, it is the Cloud Engine S series switches. For the APs, it is the Net Engine AS. And for the wellness device, it is the AI Engine APs. And for the security device, the high-stack engine AI firewalls can be managed by the platform. And for the APs, you should find that now the AI Engine APs, I mean, not every one of them, some of them can support the IoT modules. It means it can offer the connectivity to the IoT device. Now, let's say what is plug and play. And I have already said it before. Plug and play, it means after the device are powered on and connected to the internet, they can obtain the IP address of the controller, and then they will register to the controllers. And what is the result? The result is all the devices will be registered to the controller, and you can manage them on the MSNCEs, and that is plug and play. And now let's look at a different method of the plug and play. The first one is we can use the Cloud Campus apps. It means the first step is we know that for the AP, and actually it's only AP support this way. For the AP, we have the QR code on the APs, and you can use the app to scan the code, and then the apps will obtain the ENS numbers. Notice ENS numbers and MAC address of the APs, and then it will report the information to the controllers. And you should know that, and we will know that the AP will try to register to the controllers, and you should know that we needed to add the information, which information ENS numbers to the controller, and then you will find your device. And another way is through the registration centers, and I have already said it before. Just you need to synchronize your device information to the registration centers, and for all the device, AR, firewall, and switch and APs, if they, for example, after they power on, they will try to send a message to the registration centers, and this centers is built in the device, and it is the domain name. So it means all the devices will try to obtain the IP address of controller to the register centers, but it is not the only way that is supported by the device. For example, you can specify the controller IP address by the web system or the command line. It means you can log in the device web page or log in the device's command lines, and you can configure it on the web page, or you can configure it on the command lines. And another way is through the DHCP options. And I have already demonstrated it before in the last day's experiment, in yesterday's experiment, and you'll find that all the device after the power on. So what it means after the power on, besides the packet to the registration centers, besides this packet, it also will try to obtain IP address by DHCPs if they can obtain IP address by DHCPs, and if the the DHCP packet carry an option 100 and the 48, and it will try to pause these options and try to get IP address. So it means two-way two packets, the device will try to get the IP address of the controller. The first one is it will try to send a message to the registration centers, and another way is it will try to open IP address of the controller by DHCP. And another way is the email-based deployment, and it is only supported by the AI routers. So what it means? It means you have already do some configurations, and these configurations is on the Amazon NCEs, and then you will download, and then you click the Amazon NCEs, click the email to the email service, and then you download the email. What will be included in the email? It is just a link, and this link, it includes the command line that can be recognized by device. And then, for example, you have already downloaded the emails, and then you connect your PC with the AI routers, and then you click the link. This link have IP address, and this IP address should be the default management IP address of the AI routers. And then you browser will try to send the parameters and that carried by the link. You can know that. If sometimes you click one link, these links have so many parameters carried by it, and all the parameters will be sent to the AI routers, and the AI routers can recognize the command that carried by the parameters. So what is it? It is, you can think, just we convert the configurations to a link. And this link will, if you click this link, I mean, you have already connected your personal PC to the AI routers. And if you click this link will be sent to the AI, and AI will try to recognize the command lines that carried by the link, and then it will execute them. That is the email-based deployment. So you can think about what command lines can be included by the link. For example, the IP address of the controller and the IP address of the uplink, and so many configurations can be included. That is the email-based deployment, and it is for some scenarios. For example, this AI router is the egress device and is connected to internet, and you don't have a registration centers, and you don't have a device that can offer DHCP packet to it. So you can choose route ways, and you can find that it is only used for AI routers. Now, let's look at the technologies about these solutions, and I think you have already been familiar with it. It is the cloud management. So what it means? It means all the things that the controller can do, you can use the cloud platform. The cloud platform is offered by Huawei. So all the things that the controller support, you can do it. Just you don't need to deployment a controller that by yourself. You can just buy account that offered by Huawei. So now let's look at what is the highlights of our solutions. I mean, for the small and medium-sized network. For example, the first one is automatic deployment, and it shows that all the devices can be easily and quickly deployment. And the next is cloud-based, just because we have a cloud version Amazon NCEs for use, and we have so many devices that support these scenarios, support these solutions. So we have diversified product portfolios, and besides that, all the devices can be managed by the cloud, and they can still management by the command lines or by the web pages. So we call it the dual working mode. And besides that, we see that the platform, the Amazon NCEs, can offer the APIs for use. So what is the benefit of the APIs? It depends on you. It depends what you can do by analyzing the data that of your network. So now let's look at the design of the small and middle-sized campus network with our solution. The first part, it is the overall design. It is about the management mode and OM mode and the license scheme. First one is the management mode. We have seen that before. We have two versions for you. The first one is the, or maybe you can choose three versions. For example, the expensive ways is you deployment, you purchase the physical service by yourself and you install the platform by yourself. So we call it the on-premise. It means you buy a service and this service have already been installed the platform, but it means you need to cost a lot of money to buy the physical service. And another two way, you don't need to buy the physical service because the service, the platform is based on the Huawei public cloud or the MSP owned platform. It is just a service provider, all right? It is service providers. It means the service providers will deploy the Amazon CEs, and then they offer the platform for you, and you can just buy account by them, or just you can buy the account from the Huawei. And actually, I think for the two version, actually I think they are the same. Just the service provider is different. It is Huawei or other company. And another is the operation and management mode. We have two modes for use. The first mode is the enterprise management, and another mode is MSP management. So what it means? It means you management your network by yourself, or your network is management by the MSPs. It depends on your scenarios and your choice. And you can find that actually it's the MSP, it means the service provider. The service provider, this account, it can authorize the operating and management right to you, and then you can manage it by yourself. Otherwise, if you think you don't have the ability, you think it will cost a lot of time and cost, and you need to employ the skilled a person with experience skills. Maybe you can think you will think I just let the MPSP let the provider to management the network. And then the next part is the license mode. For the license mode, we have different modes. The first one is for the first scenarios, it means you buy account from the Huawei public cloud. We have the online transaction and offline transaction mode for use. For the online transactions, it means the license can be purchased online from the Huawei cloud, and the license pooling is not a spot in the mode. But for the offline transactions mode, it means license activation codes need to be logged on the cloud campus cloud this platform. It means you buy the code and you need to input it on the platform by yourself. And if you choose the MSP owned cloud, it means if the platform is offered by the MSP, it means MSP have already purchased the license, all right? And it means MSP have already installed the license on the platform. So you need to buy the license offered by the MSP. And actually, you just buy the user right from the service provider. So you will find that it is just the offline transactions. Now let's look at the license consumption of the termination mode. We have two modes. The first mode is the call termination license mode. Another one is a non-call termination license mode. What is different? It means the first mode, it means the license are pulled and shared by all device and call terminated for all device. Call termination of license cannot be undone. Therefore, the license termination time must be properly designed. It means the license is used for all devices. So for different type of device, You don't need to buy the different type. And another type is for different the lesson support and shared by device type. You should find that is for the device type. It means lesson results are exclusive to device of one type and not shared by device of other types. So you will find that license for different type of device terminals separately, but for one type, they still terminate at the same time. Now let's look at the network design. First is the network architectures. We have the different network architectures. For the internet architectures, we have the single device networking architectures and single layer network architectures and two layer network architectures. For the for the mini scenarios, for the mini source, maybe we just use a single device. You can choose the networking architectures, just depends on the terminal numbers and the skill of your network. And we still have the three-layer networking architectures. You will find that it is like the traditional networks, but just because the controller is the current versions. And if you want to have a high abilities, you can choose the highly reliable networking architectures. You can find that for the application and calls, we will deploy the stack or CSS technologies, and we will use the trunk terminologies. And for the one interconnections, we can choose different ways. It means for our controllers, it is about the abilities. We call it the SD1, and you will learn it in the next lessons. And you will find that we can build a VPN. It is a logical networks, and for this logical networks, you can choose different the logical topologies. For example, you can choose the hub-spoke or the full mesh or the partition mesh logical topologies. It depends on you. It depends on your requirement. And so now let's look at what is the network architecture's design considerations. The first one is you need to determine the intranet architectures. This depends on your terminal numbers of terminals and your requirement. And then we need to consider the one interconnection mode. And you should know that it's a logical topology. It depends on your requirement. For example, for the small branches, all your branches just need to communications with headquarters. You choose the further types. But if the branches they need to communication with each other, maybe you need to choose the full mesh networking. But for some scenarios, you just have part of the branches can communication with each other. Maybe you can choose the partition mesh networking. And for the reliability requirement, you can just choose if you use the stacking technologies, if you deploy the trunk, or if you use HRP, if you purchase two firewalls. It depends on your requirement. And then next, it is about the networking scheme. It means for different scenarios, you need to choose the different networking scheme. For example, if your network skill is less than 15 terminals and area is less than 15 meters, now maybe you just choose the single device. For example, you can choose the AP or AR or the firewalls to function as your user's device. And actually, it is the only device of the network. And if your network skill is larger, and for example, it's just like what we said in the slide. For example, you can choose X gateway and plus APs. For example, you can choose the AR routers or the firewall to function as the gateways, and you can choose the AP to expand your network skills and offer the wireless connectivity to terminals. And for the AR routers, it also supports use the 3G or the 4G links to function as the egress link. And if your skills is larger and largest and the small largest, and maybe you can choose the egress gateway, layer 2 switches, and the APs to construct your network. And if you want more, if your network skill is more larger than previous one, maybe you can choose the egress gateway, layer 2 switches, and the distributed APs. And I think this is suitable for the school or for the hotels. And just we can find that we have the remote unit. Remote unit is used for the dense room buildings. For example, you want every room have the separate wellness APs. You can choose these architectures. So how to choose your scheme? It depends on your requirement. For example, for example, if you want the wellness connectivities, you need to choose APs. And if you want every room have the separate APs, you can choose the remote unit and the central APs. And if you want high security levels, maybe you can choose the firewall to function as your egress device. So you can find that all the network skills and the scenario decide which network mode you will choose. You can just choose the most suitable modules. Just depends on your requirement. And now, next, let's look at the reliabilities. And I think for the campus network, you should know that what is the most used technologies. For example, for the link level reliabilities, maybe we'll choose the eLearning, and we will choose the dual active links. Or for the device level reliability designs, maybe you will choose the CSS or the ASSEC. Or for the firewall, you will choose the HRP technologies. And for the whole network level reliabilities, maybe you will choose combine the link level and the device levels. And I think you should know that this is a typical high reliable networking architectures. You can find that for the switches, it uses the easy-trunk technologies, and they connected to a logical switches. And between core switch and aggregated switches, they use the easy-trunk, and all of them deploy the CSS or the ASSEC technologies. Now let's look at what is the link level reliability designs maybe you consider. For example, for the internet link, maybe multiple links can be deployed between switches, and bound use easy-trunk. And switches, if they support the ASSEC or CSS technologies, maybe it will be recommended that easy-trunks be used across switches to issue link reliabilities. And for the egress link reliabilities, maybe if we only have one device but multiple egress links, all the multiple device, at least one egress link for each device scheme. Okay, all the scheme can use for the different scheme. For the different scenarios, we use different topologies. You can find that for the single device dual egress links, which use these topologies, every different egress links should belong to the different service providers. And if we have the dual egress links, we should use these topologies. We need to connect the two egress device, and maybe we can use the root technologies or other technologies. For example, for root, we only can use the root technologies to build a redundancy root path to the egress network, to the external networks. But for the HRP, maybe for the firewall, maybe we can use the HRP technologies to use the logical address. And next, let's look at what is the device level reliability designs. For example, for the egress firewalls, we can deploy them in the hot standby mode. And for the AI egress gateways, we can use this physical topologies, and maybe we can use the OSPF or the static routers to achieve the redundancy network. And for the switches, between the switches, we can use stack technologies. And now just let's combine the link levels and device levels to look at what is the network level reliability designs. For example, for the egress device, we use the dual device. Maybe they can either active standby mode or the active mode. And we can use the multi-links, and the different links should belong to the different service providers. And for the intranet, we can use for the switches, we can use the stacking technologies, and for the multi-link that between switches, we can use the trunk technologies. And then next part, it is about the WAN interconnection. Now let's look at what we should consider in the WAN connections. And this part, it is about the SD-WAN. It is about SD-WAN. It means the WAN connection between branches. For example, so you can think IPsec and L2TP, all the technologies that is belongs to the link between branches. For example, we can choose the static IPsec VPNs. It means our controllers can support the traditional static IPsec VPNs, and by using these technologies, you can connect branches with the head connectors or build the connectivities between different branches. Or you can use the Huawei private SD-WAN interconnection technologies. It means we will use the EVPN to establish tunnels between sites, and just by use one logical tunnels, we can carry traffic that belongs to different virtual networks. You will find that it is like the logical network. And now let's look at what is interconnection networking modules. And I've already said it before. We have different modules. For example, hub-spoke, full mesh, and partition mesh. It depends on your requirement. And for the physical, for the egress device, how to design it. For the egress device, you can use the APs, ARs, or the firewall. All they can function as the egress device, and they support different the physical topologies. For example, you can find that if we have two firewalls, we can use these topologies to build our egress layer. And what is the SD-WAN solutions overview? So you find that we will use a controller. It is MSNCEs, and MSNCEs can also manage the AR routers, and they can build the logical network between the AR routers. It's just like we built a logical network between different branches, and by this logical network, we can just deliver the traffic from the different virtual network or the logical network that we deployed on our branches or the headquarters network. Now let's look at what is the solution overviews. For example, for the network module designs, we can use the single layer models. It means one side of the enterprise can be directly connected or connected through one or more hub sites. Typically, this mode is used by small and middle-sized enterprise as well as large enterprise with fewer than 100 sites. And also, we can use the hierarchy mode. It means this mode is applicable to large enterprises that span multi areas. In these modules, the entire overlay network is divided into multiple areas. Traffic between sites in different areas is forwarded through a body size. But I think actually in our scenarios or in our live networks, we seldom use the hierarchy mode. And for the physical network designs, we can use the single AR routers to function as the egress device. And otherwise, you can use the multi-link and dual AR routers to function as the egress routers. Now let's look at for the SD-WAN solutions, what is the service design? For server design, we need to design VPN. So I have already mentioned before. So SD1, it is still the logical networks. So what can remember? What can when we're talking about the logical networks? For example, in the campus network, when we're talking about logical networks, it means we can have different logical networks on the virtualized network. For the SD1, it is the same. We can use the different which network or the logical network. So we call it as a VPN. And also for the SD1, the logical network is defined based on it can be based on the different physical networks. For example, the MPLS links and Ethernet links and the controllers can make intelligent traffic steering. For example, if the controller dedicate your MPLS link is not its quality is not good, and the controllers can steer your traffic to another link. And also it supports the queues schedules. For example, it can schedule the different type of traffic to different links. And for security, it supports ACL-based traffic filters, URL filters, firewalls, and IPS. And all the functions can be supported by AI routers or the firewall. And it also supports the site to internet access. It means all your traffic can go to the internet by the local egress device or by the headquarters local device. It means if you choose the HQ's egress device to function as your internet entrance, it means all the traffic will be transmitted by the logical network to your headquarters, and then headquarters will send it to the internet. And as well, this logical network can interworking with the traditional networks, just like for the campus network, it can also connect communication with the external network. All right. Now let's look at the last part about the design. It is the server design. First, it is a network basic service. And I think you will be very familiar for this part. All right, it is just about how to design your traditional networks, and it will be a theme by the controller. The first part, it is about the VLAN. For the VLAN, I think you must be experienced with it. Just classify VLANs into the different types. For example, server VLANs, managed VLANs, and interconnection VLANs. And just allocate consecutive VLAN IDs to ensure proper use of the VLAN resource. Or you just need to reserve a specific numbers of VLANs for the future use. And typically, VLANs are divided based on interface or according to different design principles. Interface of 6 switches are added to different VLANs so that use of different service typical can be assigned. So I think you should be very experienced about this part. And for the IP address plan, it is the same. We need to design the management IP address and the server IP address and interconnection IP address. Normally, you should know that we just use the 30-bit mask for the interconnection IP address. And normally, we use the server IP address. We will use the last IP address of the subnet to function as a gateway. And I think you should know that you must be very familiar for this part. And for the egress device, we can choose. You need to design the method that connected to the service provider. So we can choose the PPOE mode, DHCP, or the CTIC. And for the special terminals, for example, the service, the printers, or other terminals that cannot open IP address, or they should have a fixed IP address, you need to do, for example, the DHCP static bonding for them. And for the end users, it is recommended that all the device should be opening the IP address by DHCP protocol. And for the LAN side device, for example, between the egress gateways and the level 3 switches, you should know that it is recommended that we use the VLAN if to communication with each other. And for the egress gateways, it is recommended the DHCP survey will be deployed on the gateway. So, for example, for the APs, they will get opening the gateway IP address, and then it will generate the default router and which router's next hop is the gateway. And for the routing designs which follow these rules, for example, the CAK routers are recommended for small and medium-sized campus network, and internal routing design of the campus network. For the APs, you should know that after the AP opening IP address, it will generate a default router by itself. And for the switches and gateways, we recommend use the static routers. And for the campus egress, we will advise just use the static routers on the egress device. And maybe you need to configure the default routers and the routers to the terminal subnet. And the next part, it is the network deployment. And we need to choose the, for example, we can use the automated network deployment. For example, we can use the plug and place, we can use the email deployment, or use the registration centers. It depends on which one you can choose. It depends on which one your network can offer. So you can find that we have tables that for different devices, which type of registration they can support. And for different device, I think you can choose. You need to choose the way of your egress gateway registrations. Just because if your egress device have already registered to the controllers, you can let the LAN device to register to the controllers by the egress gateways. So how to choose it just depends on your device, and it just depends on if you can offer the DHCP functions or if they can connect it to internet. So we have tables for different scenarios. For example, for the public cloud scenarios, and the egress device can obtain IP address by the DHCP service. So you will find that maybe you can use the registration centers. And next, let's look at for the LAN side, how to design the device registrations. You still just depends on local the scenarios. For example, you can configure the DHCPs. So if you can configure it, you can use the registration centers or the DHCP options to register to the controllers. So just choose the suitable ways for your device. Just depends on your scenarios. Just depends on if you can offer the, for example, email service, or if you can offer the DHCP options for your device. And the controllers support scenario-specific deployment. It means that you can to make typical scenarios, and when you create your sites, you can just use the scenario template, and just you can use it to accelerate your management of your controller by using the controller. What is the next part? The next part, it is about the awareness. In the awareness part, we will consider about from the plan to the networking, from the WLAN plan to the networking plans, and consider about SSD plan, and how to design the rooming of the WLAN and the radio calibration. The first part is the WLAN plan. We need to consider about the awareness signal coverages, and we need to consider for different scenarios what is the requirement of the scenarios. For example, for the dormitory rooms or libraries or hotel rooms, you can find that the signal strength requirement is different from the kitchen storerooms, and the dressing rooms is different. So you need to consider about it. And for the physical coverage reference for the indoor scenarios, outdoor scenarios, you can find that the coverage of the recommendation is different. For example, for indoor scenarios, we just need to plan the coverage radius to the 15 or the 20 meters for each APs. But just you will find that for different scenarios, the value is different. Just depends on which scenarios you use. And another one is the signal coverage. We need to follow those rules when we deploy APIs. For example, when we install an APIs, just to try to reduce the number of the obstacles that signals pass through, to ensure that the front side of the AP faces the target of coverage areas for full coverage. And you should place APIs away from the interference source, such as the electronic device. Do not deploy microwave ovens, wireless cameras, wireless phones, or other electrical devices in the coverage areas. It means if the device will generate maybe the wave or other signals that maybe take affections to your wireless signals. And for the areas with roaming requirement, you should keep at least 10% to 15% signal overlap between the coverage areas of the neighboring APs to issue small station roaming between APs. So for the WLAN planning, we said it before. So we can use this WLAN platform, and we have the links. And by using these links, you can do the WLAN planners. And you can find that you just need to upload you can upload your maps of your scenarios, and then you can try to put the APIs on different scenarios. And actually on this platform, you can see what is the coverage of your APIs. And now let's look at what is the networking plannings. The first is the AP numbers. It determines the how much and which modules you choose. How many access switches you select. Just because we recommend that you use the PoE switches, all right? And the numbers of the access switches, it determines the number of switches based on the number of APs and access relationships and the number of the ports on the selected switch. And then it is about the SSID plannings. For example, for the SSID server plannings, you should know that an SSID represents a type of service, plan the number of SSID based on project requirement. Different authentication modes can be deployed of different SSIDs. SSID can also be used to distinguish different groups of users or different service or permissions. For example, employees and guests are configured with different SSIDs. Authentication and encryption modes for the SSID. Usually means you can know that for different scenarios. For example, if the SSID is offered for the guest, you shouldn't use the .1x or the MAC address authentication. You should know that the portal is recommended. But for if the SSID is used for the employee users, you should know that the .1x is recommended. And another thing it is about SSID plan. It is the SSID parameter settings. For example, you need to select the effective radio rate, all right, and you need to plan the survey VLAN corresponding to the SSIDs and configure the corresponding gateways and IP address. Advanced survey parameters. For example, if you choose the balance steering, the user isolations, and the SS headings, or it depends on your requirement. And for the application functions, if you choose to limit its rates, or if you need to limit the access right, or it depends on you. And the next part, it is the roaming. And the first one is the layer 2 roaming designs. So now let's look at what is the definition of the layer 2. It means before and after the roamings, the station still belongs to the same subnet. So it don't have any requirement. It is just a requirement for the two APs. The survey VLAN are the same. So you will find that is simple. So you just need to make sure two APs have the coverage have a overlap, and then you can make a successful roomings for the level 2s. But what is the level 3 domain? And so let's look at the definition of the level 3 roomings. It means before and after the roomings, the survival line changed. But we need to keep the IP address of the rooming station unchanged. So that is well, all right. So it means the station traffic needed to be deployed to an AP that resides on the same segment of the AP through which the station goes online for the first time. So what it means, for example, for these terminals, it changed from the AP1 to AP2, AP1 to AP2, and after it changed to the AP2, finds that the survival line changed. But what is rooming? Rooming, it means the terminals should not have any feelings about the changes. So it means its IP address should not be changed. But for this subnet, it don't have the ability to offer the service for this subnet. So how to choose? It means we will use a tunnel. This tunnel will send the traffic to this part, to this area, just because this area it has the abilities to offer the subnet that for these terminals. So that is the level 3 roomings. And now we will have a new terminology. It is the home APs and the fast APs. What it means? Home AP, it means the AP that is the first goes online, so we call it as home APs. And what is the foreign APs? The foreign APs, it means the terminals changed to another areas, and this area have a different survey lines. And the APs that are connected with the different subnet, we call it as foreign APs. So what should be what needed to be mentioned? We should use technologies that we call it William Paul. Just because, for example, if this AP and this AP and this AP, they have the different surveillance, it means if these scenarios, for example, if this AP is used for the hotel, the room, just because, for example, maybe this AP will access so many terminals, but just for one time, and they all roam into other APs. What is the result? The result is for this AP, for the foreign APs, it only have one home AP can choose. But if it uses the home APs, it means all the AP can function as home APs, just because all the APs have the same William pool. So all the APs can function as the home AP. Okay, now let's look at what is the radio calibrations. We need to use the AP group designs. So what is the AP groups? The AP groups, when it means we will use the lead AP, and this lead AP can manage these groups. But a lead AP, it is still a AP. The AP that it can management it have a limitation. So if the number of APs exceed the management capabilities of the lead APs, network planning is required. It means management VLANs needed to be planned for AP groupings. When there are a large number of APs in management VLANs, the APs are automatically divided into multiple groups. So it means we can use the random grouping. And if the radio calibration is performed on WLANs in continuous areas, therefore it is recommended that AP be grouped by geographic locations, such as by floor, to ensure that AP in a group are in the same areas. This maximizes the calibration efforts. Just depends on the scenarios. And now next part it is the calibration mode selections. MSNCE supports 3 radio calibration modes. The first one is the automatic modes. It means APs will periodically perform global calibration based on the calibration time and interval. Another mode, it is a manual mode. It means the AP will not proactively perform radio calibration, and you need to manually perform global or local calibrations for AP at the site on the MSNCE. And the third mode, it is a scheduled mode. It means AP will perform global calibration at a scheduled time every time. And AP will perform calibration dedication according to the configured mode and switch it to other channels and scale neighboring APs. The scanning lasts for 15 minutes. During the dedication, the AP report the dedicated data to the lead AP every 10 a second. The lead AP performs the computing and calibration every 5 minutes and performs the computing for 3 times to achieve all of them coverages. The lead AP delivers the calibration result to each AP in the group, including the calculated channel and powers. So we find that the lead AP will deliver the calibration, the Amazon NCE will deliver the calibration commands, and the APs will perform the dedications, and the lead AP and the APs will report the dedication data to the lead APs, and then the lead AP will perform the computing and the calibrations. And the next part about the radio calibrations, it is the channel and the frequency bandwidth. For example, for the AP channel selections, for the 2.5Gs and for the 5Gs, we have the different channels can use. For the 2.5Gs, you know that the channel should be set by a step of 5. If the AP are densely deployed, maybe you can choose the 1, 5, 9, and 13. It is can be used. But for the 5G, you can know that we have so many frequency band can use. So if you have two, the wireless radios, you can choose to put one in the high 5G radios and another in the low frequency respectively. And for the frequency bandwidth sections, for the 2.5G frequency bands, we only recommend use the 20 amperes just because it is not recommended for you and impossible for you to do bandwidth banding. But for the 5G, you can use the frequency bandwidth. It means you can do a band and you can do bandwidth. You can do the bandings if you have high qualities about the bandwidth. And then let's look at the NUC, this part, the design for NUC. And the controller support different scenarios for the access controls. For example, the controllers can function as the authentication service. You should know that they can support as the readiness service, the follow service. All right, or you can choose to let the Amazon NCE just function as an agent. That means all the packet will send be to the controllers, and the controller will send it to the third-party portal service. It means we can use the controller to in connection with the third-party portal service, and the controller can also to function as the agent for the radius protocol. It means you can use the third-party radius service, and your authentication packet will be sent to the controllers, and the controller will send it to the third-party radius service. And if the authentication point directly in connection with the third-party authentication service, it means what it means. It means the controller just pushes the command to the device, and the inside the command is that pushed by the controller. It will include the IP address of the third-party portal survey or the radius survey. And for the authentication solution deployment, we need to consider about the authentication point for the wireless users and the authentication point for the wired users. For the different type of users and different type of terminals, we can choose the different method of authentication. For example, For the guest users and use the wireless, we recommend to use the portal authentications. And for the enterprise employees and which use the wired or the wireless access, we recommend use the portal authentication or the .1 authentications. And but for the dumb terminals, we recommend use the wired access, and the MAC address authentication is recommended. And which point to choose to function as the authentication point? For example, we normally recommend you to use access device to function as the access point. And but if you can't do it, maybe we need to use the policy authentication technologies. And for the networking scenarios, the single device networking, for example, the authentication point is in the local device, and the portal authentication is recommended. And other network scenarios, AP are used as the authentication point for witness users, and access switches are used as the authentication point for web users. And the last part, it is about the WAS and the OM. And I think we just to know that the Amazon NCEs can offer you different open APIs. For example, the infrastructure APIs and the third-party authentication APIs and the LBS APIs. We can offer you different type of APIs, and you can use the APIs to do the analyze or build your software by yourself. And you can find that in these figures, you can find that the physical device can support different protocols that communication with the controllers. For example, the netconf, telemetry, syslog, SMP, and netstream. All these protocols will offer the adequate information for controllers to collect data. And you can find that the APs in our scenarios, in our solutions, it can support the ZigBee and Bluetooth and RFID. They can support these modules, and by using these modules, our APs can support the IoT device. And for the network management designs, we need to consider about the management levels. And the key point of this part, we need to consider about consider about how to design our site and organization. And you will find that for the platform carriers, we will have account with the highest right, and below it is MSP account, and then MSP account can create different tenant. And for the tenant, they can create the different organizations that belong to different sites. So you need to consider about how to design your account by the different levels. And another is about the count with the different rights. And you can find that the rights and domain-based management, we need to consider about the authorization scopes. It means we have the different types of account, and we can authorize the account with the different rules. So by using the rules, we can control the functions that can be performed. For example, for the tenant levels, the super administrators can grant different rights to tenant administrators, and they include the monitor, open APIs operators, and tenant administrators. And for the MPSP levels, the super administrators can assign different rights to MSP administrators. For example, they include the monitor, open APIs, and MSP administrators. But normally, for the management personnel of the MSP or the tenant, we just need to use grant the administrator right to them. And then next, it is the domain-based controls. We can control the range of the devices that an administrator can management. It means we can just for example, all the device we can fancy it on the MSP, and If this account can see this device, we can control it by the MSP administrator. And the next it is the OM functions that provide for the Cloud Campus apps. You can just think that it is the figures that show you what is the abilities for the Cloud Campus apps. And if you have the chance to use it, you will learn about it. But just know it. Just know the Cloud Campus apps can have these abilities. And at last, let's say two simple questions. The first one is, which of the following device deployment solutions can be used on small and medium-sized campus network to issue device reliabilities? The first is the deploy firewalls in hot standby. Yes, it is right. Deploy to AS to egress gateways. Yes, it is right. And to deploy switch in staging mode. Yes, it is right. And deploy multi-class link operations. Yes, it is supported by this. And the next it is another question. It is the if .1x authentication requirement for Wi-Fi networks deployed in installers. And if the Wi-Fi is used for employees, yes, it's right. But I think it is used for the guests. So .1x is not recommended. We recommend to use the portal to function as the authentication protocol. Now let's look at the summary for this lesson. This course describes how to use Huawei Cloud Campus cloud management network solution to design small and medium-sized campus network. Key design points include the overall design. It includes the network management mode design, network OM mode design, and license scheme designs. And the network design and the service designs. And I think by the design guide, you should know that what things we need to consider when we try to deploy a small network for the small and medium-sized network if we want to it to be management by the campus network by our controller. Okay, thank you. That is all the content for this lesson, and we can take a rest for. Okay, we can take a rest for 10 minutes, and then we can start it again.